It's my pleasure to introduce Christopher Chabris. He's visiting here today. He's coming to us from Geisinger Health Services. And Chris has done a lot of great work on collective intelligence and success in teams. And he's going to present, I think, an overview of some of his work on collective intelligence. And we're excited to have you here as our visitor. And
all right, thanks a lot. Thanks everyone for coming. All the work I'm going to present is in collaboration with the people listed down below, who are funders, collaborators, co-authors, and some students as well. So I'm at Geisinger Health System in Pennsylvania right now, but I was before that for 9 or 10 years at Union College in upstate New York. So there are a couple of Union College students listed there who collaborated on some of this work. In case you have heard my name before, it might be in connection with a study about a gorilla, but there are not going to be any gorillas in this talk. As Chris said, I'm going to really give like a pretty broad overview of some of the work we've done on collective intelligence going back about 7 years up to some work in progress right now. And how much time would you like me to consume? When does this slot end?
The norm here has been 30 minutes, right?
30 minutes? Okay.
Plus questions.
Plus questions. Oh, okay. All right. Well, nobody told me that, so I'm going to skip a lot. I'm going to skip a bunch of slides. So if I get close to the 30 minutes, give me like a 5-minute symbol sign or something like that.
Good.
Okay. So I'll skip quickly through the motivation. I mean, as we all know, over time, work has become increasingly based on teams. So when Darwin wrote The Origin of Species, it was written by one guy, Darwin. Even 100 years later, the paper on the structure of DNA was written by 2 people, Watson and Crick. There they are. There's the author block right there. Not many references either, by the way. Then 50 years after that, the sequencing of the human genome, the one page that Watson and Crick's paper is just the list of authors on this paper now. So science is becoming increasingly a team activity, and there are parallels in many other fields of human endeavor. So medicine is increasingly team-based. Over half of articles produced in natural and social sciences are authored by more than one person. That was as of 10 years ago. I'm sure you will know it's probably gone up since then. And crucially, many groups perform a wide variety of tasks rather than repeatedly do one particular thing. So what I'm going to be interested in this line of research is looking at whether groups of people who work together, typically small groups, like in our studies they've ranged from 2 to 5 people, not large crowds, but small groups working together. The idea that small groups can be characterized by different levels of collective intelligence that have something to do with how those groups perform on a wide variety of tasks. So the intelligence of groups and small teams is important because of situations like this. Here's a famous group of people who are presently collaborating on a particular task. They are, of course, watching the raid to assassinate Osama bin Laden. However, these same people had to do a lot of different other tasks together over the course of their time together. They weren't composed as a team just for this one task. They didn't do this one task repeatedly over and over again. They did lots of different things. So this is the kind of collective intelligence I am talking about, small groups of people working together to solve problems. The issue that I'm addressing is not whether the group comes up with better solutions than any of the individual members do, or than any of the individual members would have if they had done the task on their own. The issue is whether some groups are smarter than other groups, and in particular why some groups are smarter than other groups, and ultimately how we can make groups smarter than they already are. So for example, many people would argue that this group was smarter than this group, a group of people in the same roles, but who making similar decisions, but who arguably made worse decisions when they had the opportunity. All of these groups, by the way, are composed of intelligent people. The issue is not that there's a bunch of stupid people in one group and a bunch of smart people in the other group. Perhaps something about the composition and the interaction of the group members is going on as well. So many groups perform a wide variety of tasks rather than repeatedly do one particular thing, but smart people can choose horrible group processes. So, for example, I once interviewed a member of the US intelligence community, an intelligence analyst who worked for some government agency, and I said, give me an example of a situation where a group made a collective decision. And he said, okay, so we all had to estimate some quantity, like the number of nuclear warheads in the Soviet arsenal or something like this in the 1980s. And so the way we did it was we all got together in a room and we went around the room in order of seniority, from the most senior person in the room down to the least senior person in the room, each giving our opinion. And if you know anything about group processes and so on, it's hard to imagine a worse method for aggregating well the different contributions and information of individuals than to start with the boss and let everyone follow his lead. Now, the CIA, the US government, whatever you may think of them, they actually recruit very smart people. The CIA especially recruits from top universities. Most of them have master's degrees and so on. So the intelligence of a group as a whole might not be determined just by the intelligence of its individual members. There can be other things going on. I'm going to skip past, well, I'll pause on this slide. So after we had been doing this research for a while, I came across this quote from Aristotle. And in psychology, of course, we like to start by quoting William James, just like the communists have to quote Lenin, or the Soviet communists at least had to quote Lenin. We like to quote William James, but here I was able to go back all the way to Aristotle, who wrote, "For each individual among the many has a share of excellence and practical wisdom, and when they meet together, just as they become in a manner one man who has many feet and hands and senses, so too with regard to their character and thought." So my interpretation of Aristotle is that he was saying that sort of a group of people working together can kind of be thought of and analyzed like an individual. In a way, they have sort of one character and one thought process. And that sort of informs or illuminates the approach that Anita Woolley and Tom Malone and I took to answering the question of collective intelligence of groups. So we basically borrowed the entire research approach from the study of intelligence of individuals. So we thought of, if the group is like an individual, how has intelligence in individuals been studied, and can we sort of copy that same research program but just apply it to groups instead of individuals. So the next part of the talk is going to be a brief sort of summary of 100 years of research on individual intelligence, which we will then, in the rest of the talk, apply to the intelligence of groups, small groups, teams. So here's a study that I did a while ago that had nothing to do with really general intelligence at all. I was applying a lot of cognitive tasks to a fairly large group of people, about 110 people. And I've named the cognitive tasks on the side. Each of these 110 people did all 7 of those tasks. And this is a correlation matrix of performance on those tasks. So each entry in the matrix is just the correlation between performance on task A and task B for those people. And the main thing to note is that with the 2 exceptions, which are almost 0, they're all positive, and many of them are nominally significantly positive. So people who do better on the working memory task tend to do well on the Raven's Advanced Progressive Matrices task. People who do well on the verbal fluency task tend to do well on the working memory task, and so on. Even those tasks down at the bottom, which are fairly simple tasks, categorical and coordinate spatial encoding tasks, are tasks where there's a dot and a bar on the screen, and you just have to decide how far apart the dot and the bar are, or whether the dot is above or below the bar. Very trivial cognitive tasks seem to correlate positively with other cognitive tasks. So, if you do if you do this sort of thing repeatedly and look at a lot of data sets, you'll see that this pattern recurs over and over again, and it can be called the law of general intelligence, which is that measurements of cognitive ability tend to correlate positively across individuals. This was first discovered by Charles Spearman over 100 years ago, and has since been confirmed over and over again. I would say it's one of the most replicated empirical observations in psychology. And if you do a principal components analysis or some other kind of factor analysis on this data, you find that there's a strong first principal component or general factor, often labeled G, sometimes called the G factor or general intelligence. And here, these are the G factors from this particular data set. These are the G loadings, I should say, calculated from just doing a simple, unrotated principal components analysis. And interestingly, some of the tasks are more correlated with the general factor, the first principal component, than others. So the Raven's matrices task is listed first because it's the most G-loaded. That one task is the best single indicator of general intelligence out of all the tasks that people did, whereas that simple categorical task is not as good an indicator, and the others are in between. Now, The G factor or other methods of inferring sort of a general ability factor from this kind of data is not just sort of an epiphenomenon. It actually has a lot of biological correlates as well as genetic correlates. So these are all things that correlate with measures of general intelligence. So the volume of your brain, volume of your gray matter, the volume of your white matter, the volume of your prefrontal cortex, and various other things. Interestingly, even simple response time, which is how long it takes you to press a button after a light goes on, in a situation where there's just one button and one light, that's why it's simple response time, there's no choice. Even that correlates significantly with measures of IQ or general intelligence. It's not just a human, yeah,
Just
question?
to clarify, that's within a person. All of the test results are within a person in your last slide.
This one?
Yeah.
So each correlation coefficient, so 111 people each did all 7 tasks. And then I am correlating each task with every other task across those 111 people. So people who do better on task A tend to do better on task B if there's a positive correlation between tasks A and B.
Okay.
Does that make sense?
Mm-hmm.
Okay. So there are biological and genetic correlates of these differences in ability. I won't go into those too much more. But I do want to add that they're also not just a phenomenon of human beings who have experience in taking tests, and indeed, nowadays have a culture of taking tests and learning how to take tests and repeatedly taking tests. So when mice don't have the GPS and they have to solve the maze all by themselves, you can give mice a number of different mouse-appropriate cognitive tasks like mazes and other puzzles and so on. And when you do, and this has been done many, many times by now, you get what appears to a first approximation to be a very similar correlation matrix to what you get if you give humans a bunch of tasks. Obviously, you can't give humans the same tasks, although it would be interesting to have like giant mazes and have people walk through them. That hasn't been done. But if you use mouse-appropriate cognitive tasks and human-appropriate cognitive tasks, you get a similar situation where the first principal component tends to account for about 35 to 45% of the variance in performance, 30 to 45% of the variance. There's at least 20 studies of mice. This is one particular one. I was involved in one with cotton-top tamarin monkeys. So we had 22 of these monkeys, each do 11 cognitive tasks, monkey-appropriate cognitive tasks. And indeed, we found that some of the monkeys were smarter than others with a general intelligence factor. So with that as background, we basically took that entire research approach and swapped out individuals for teams and then started running studies. So the first study went like this. We had 40 teams of 3 people each come to the lab. These were recruited in Boston from the MIT database and people from Craigslist, I believe. Half the subjects were male. The average age was 32 with a range of 18 to 66. Fairly reasonable sample of the population. First, each subject completed an individual IQ test. This happened to be the even-numbered items of the Raven's Advanced Progressive Matrices, which was that highly G-loaded test I mentioned before. After that, the groups worked together, groups of 3, face-to-face on a battery of 5 tasks. And by the way, these groups were not necessarily, and not generally, people who knew each other. They were just people who responded to the invitation and said they could come at that particular time of the session. So each group then worked together on 5 tasks. And by work together, I mean they literally sat around a table and discussed each of these 5 tasks and wrote out an answer. And they had to submit one answer. They didn't respond individually. The group had to submit one answer. So the group is kind of now being treated like an individual in the traditional IQ research. So here are the 5 tasks. The first one was a matrix reasoning task. This is solving abstract logic problems. This was the odd-numbered items of that Ravens task that I mentioned. Later on in the talk, I'll show you what a matrix reasoning item looks like. But for now, you can just imagine it's a very abstract sort of spatial reasoning problem. They did a brainstorming task. That's a traditional creativity task generating novel uses for objects. They did a moral reasoning task where they had to read about a case of, I believe it was cheating on an exam and weigh sort of what would be the appropriate penalty and why. A shopping trip, which is a logistical coordination task. So they have to get a series of objects from a set of places, but there are some constraints, like if they get the ice cream at the first place, it may have melted by the time they get home at the end, and so on. So they have to maximize the number of points they get by getting as many of the objects as they can. And then finally, my favorite one, the typing task. In this one, they enter a Wikipedia article into a Google Doc. So they got a printed Wikipedia article, and they had to type it into a Google Doc, each of the 3 of them having their own laptop connected to a shared Google Doc. And they lost points for leaving gaps or for for duplicating each other's text and for other errors. So this is in a way a coordination task. They've got to divide up the effort and synchronize and coordinate their work. And then finally, the groups completed a more complex task. They collectively played checkers against a computer program, and the dependent measure here was how quickly they lost, or spun more positively, how long they held out. So we simply made a correlation matrix of these measures. As you can see here, these are the 5 tasks in the battery: brainstorming, matrix reasoning, moral reasoning, shopping trip, and typing. The first line is going to be the collective intelligence factor, inferred simply by doing a principal components analysis of these correlations on those 5 tasks. Then we have the average individual intelligence of the members and the maximum intelligence of each group, maximum member intelligence of each group. That's from the individual test they took beforehand. And then finally, the video game or checkers game performance. So there's the correlation matrix. This was published in Science in 2010. Old stuff by now. First thing to notice is the stuff in the red box, again, is all positive numbers, several of them nominally significant, kind of like the mice and the monkeys and the humans going back over 100 years. So, in fact, the first principal component, which we decided to call the C factor, accounts for 43% of the variance in performance on these tasks. Interestingly, the intelligence of the average individual group member and the smartest individual group member were not significantly correlated with the collective intelligence of the group, although they were positively correlated. So relatively, moderate positive correlation. It's better to have smart people on your team than not to have smart people on your team, but not very much, not that much according to this data. So this was interesting. This was an initial study with 40 teams. So we decided to replicate it in a larger study. So in the larger study, which was conducted at MIT and Carnegie Mellon, there were 579 subjects. Team size varied from 2 to 5 people. We added a lot of additional individual measures like personality measures, a measure that we called social sensitivity that I'll get to. We used a different IQ test for the individuals than we did before. We still used the matrix reasoning test for the groups, but we used a different IQ test for the individuals, so they didn't have practice on the matrix reasoning beforehand. We had the individual participants rate a bunch of factors which are thought to be explanations of why some groups succeed and others fail. And we used Sandy Pentland's group's sociometric badges to record some things like turn taking during the conversations. And to make a long story short, this is a plot of the percentage of variance explained by the first, second, third, fourth, and fifth principal components from a principal component analysis. So remember, study 1, which I talked about before, that's the red line. First principal component explained 43%. It goes down significantly to there. This is the kind of structure that's indicative of a strong general factor in the data. In study 2, with the same 5 tasks, we got a very similar plot. That's the green line. Study 2, though, actually contained 10 tasks. We had the same 5 from study 1 plus 5 other ones that we added in. When you use all 10 tasks, you get a more shallow plot, which is consistent with having a lot more measures. For comparison, the individual intelligence test we used, which was the Wonderlic test, has a very strong first principal component, and that's in part because the test is designed that way. The way IQ tests are designed is they kick out items that are not good measures of the main factor that the test is trying to measure. We didn't do that. We actually just included all the tasks that we had selected and kept them in. So we didn't try to make this, to refine this into a better test of the first principal component. This finding has been replicated again in German and Japanese samples, in translated versions, and in online samples in the US with different tasks as well. And Chris himself has been involved in a meta-analysis of all that data, which is consistent with these results. So, one interesting thing about individual IQ and why psychologists care about it, even though it sometimes seems like an obvious and trivial thing, is that measures of individual IQ tend to predict a wide variety of outcomes for people. So, educational attainment, income, health, longevity, almost sort of any positive outcome that you can think of, positive life outcome is positively correlated with individual IQ. Obviously in our studies of groups, we don't have that long longitudinal data to look at, so instead we had the groups do sort of more complicated tasks at the end of the session. In the first session it was the checkers game, and the second session was something that's euphemistically described here as architectural design. What that really was they got a sheet of paper which described a project they were supposed to make with Legos, and they got a box of Legos, and the project had a scoring rubric which said how many points they would get for achieving different things, and they had 40 minutes to make their Lego project as good as they possibly can, architectural design. This was a task, incidentally, that Anita Woolley had come up with, I believe, for her PhD thesis, and we used it in this study. And as you can see, the red bars show that the collective intelligence of the team, as measured by our collective intelligence tasks, was the best predictor compared to the average intelligence of individual members of the group outcome on these more complicated tasks. In a later study that I wasn't part of, although I wish I had been, the rest of our group collaborated with Riot Games, and they got, I should say, 248 5-player League of Legends teams to come and do an online version of our collective intelligence battery. They found that teams that did better in League of Legends also performed better on our battery. And if I remember the result correctly, I should have looked it up again beforehand. This also held prospectively. So following their performance after doing the collective intelligence battery, teams that did better on collective intelligence did better in League of Legends afterwards as well. So it seems like, and that's sort of like a longer term thing. This game, goes on for quite a long period of time. It's not just 40 minutes in the lab. So this gives some indication. I think that if you measure the collective intelligence of a small group or a team using some tool like we developed or some other alternative useful tool, you are learning something that lets you make some predictions and some decisions about what that team is likely to do in the future and on other unrelated tasks. And that's really the hallmark of the concept of intelligence, is a general ability that predicts performance on other things far outside the domain of just doing the questions on the test. Right? That's why we use GRE scores for graduate school and so on. It's not because we expect graduate students to keep on doing GREs all the time. It's because we think that the GRE is measuring something that will help us understand which students will do better and worse in graduate school. Okay, so I'll try to speed up a little bit. We did a tacit coordination game. This was mainly done by a grad student at CMU who collected this data as part of the CMU part of this study too. So 98 teams did the collective intelligence test and played this minimum effort game for real stakes, which could be up to $10 per person. So this is a 10-round game where on each round, each participant, and the participants are the members of a team, so let's say the 3 people are on a team, each make a private choice of the numbers 0, 10, 20, 30, or 40. They don't discuss. They just make a private choice, and then they find out how many points they got. And the points they get are a function of their choice and the minimum of the choices of everybody in the group. So if I choose 0, then by definition, the minimum of the group member choices is 0, because no matter what anybody else chose, I chose the minimum, and I get 2,400 points. If I choose 40, and everybody else chooses 40, well then the minimum is also 40, and everybody will get 4,000 points, which leads to higher income at the end. But if I choose 40 and someone else chooses 0, I actually lose 800 points. So this is a coordination game. Somehow the group has to get to the point where everyone is choosing 40 all the time, and then they maximize their income, but they're not allowed to talk in between or during rounds. All they see is the results of each round. And we found that collective intelligence did not predict how much teams earned in the very first round of the game, but over 10 rounds, teams with high collective intelligence, this is just the top half of the teams on collective intelligence, increased substantially more than teams with low collective intelligence, which increased only a little. And in fact, collective intelligence significantly predicted the rate of increase in earnings for the teams, and it did so even over and above the average individual IQ of the team members. So, teams with smart members did better over time in this game, but also teams with high collective intelligence incrementally over the intelligence of the individuals did better. So now, next point I'm going to go to is what do these teams look like? So I'm going to show you video clips of 2 teams doing that Lego architectural design task, and I want you to tell me which team seems like the more collectively intelligent team. This is going to be about a 60-second clip of each team, and there should be audio. I think it works. That's Anita's voice reading the directions off of the laptop for the Lego task.
all these structures, there has to be glue. So for the ceiling of the house, there has to be glue, and, I mean, sorry, for the roof of the house, there has to be glue, and for the roof of the garage, there has to be glue. So, we're gonna have to, choose wisely in how big these structures are, because we only have a limited. There's one on the wall.
All right, so that's team 1, now team 2.
Minutes to build your structures.
Anybody have any guesses? Team 1 or team 2? Which one was did better on the collective intelligence test? Raise your hand for 1. Okay, good. All right, very good. So it turns out team 1. Now I cheated a little bit. I cheated in 2 ways. One was I picked the highest and lowest scoring 3-person teams on the collective intelligence test, and then I cut 60 seconds of video of them doing the Lego task. Second of all, these are not the actual people. Instead, I had students of mine reenact the videos, but they watched, because you don't want to actually show these poor people, and so on. They watched them several times and then carefully reenacted the actual behavior on display. So a couple things to notice about the difference between these 2 teams, which are kind of suggestive. One is that the second team does not appear very motivated, obviously. However, interestingly, when people filled out those forms at the end of the session about how motivated they were to work in their group and so on, that was not a significant predictor of differences in collective intelligence. Another thing to notice is the first group had 3 women. The second group has only 1 woman and 2 men. So we'll get back to that later on. It's going to turn out as a preview that having more women in your group is correlated with increased collective intelligence, with higher collective intelligence. Questions?
It seemed like they didn't have instructions in the second group. Or
That they didn't have?
Instructions in the second group,
Yeah, they heard the same. They
Okay.
heard the same video, but the reason why it starts earlier for the first group is the first group actually starts doing the task even while the instructions are still reading. They're sorting out the Legos. This group waits for the instructions to end, and then, well, you saw what happens. But this was basically the same point, offset by a couple of seconds between the 2 groups. They also had a printed sheet as well, but for each task there was sort of like an audio version of the instructions to have standardization, across all teams and locations and everything. So we took some of these videos, we took all of the videos from the teams with 2, 3, 4, and 5 participants, the actual videos, not reenactments, and then we had other participants, Union College students, watch the videos, 90-second clips of them, and then rate how intelligent the group seems as a whole. And I'm going to show you the results from watching the groups beginning to do the Ravens matrices task, which was the most indicative of collective intelligence, and beginning to do that moral reasoning task, which was the least indicative task of collective intelligence. And what you're going to see is a scatter plot showing you the relationship between the actual collective intelligence of the team, as measured from our battery of tests, and the rated intelligence of the team as rated by our observers. So when looking at the matrix reasoning task, ratings of collective intelligence are actually quite well correlated with actual collective intelligence. So smarter teams seem to look smarter. This is 3-person teams, by the way, I should say. We started with the 3-person teams. With the the task that's less indicative of collective intelligence, the results seem a little bit worse. Still positively correlated, but not as nice a result. Now, we did this with all 4 group sizes, 2, 3, 4, and 5 people, with different observers rating each one so that they don't get sort of cued by seeing 3-person groups about what 4-person groups are supposed to look like. And sad to say, the results were not quite as nice as those first 2 graphs indicated. So when the group size was small, 2 and 3 people, Ratings seem to be, fairly well correlated with actual collective intelligence, but then with larger groups, 4 and 5 people, that went down. So I'm not quite sure what is going on here, why 2 and 3 person groups are easier to rate. It could be that you have more interactions between the same people to react to. But it does seem there is some information in just observing these groups that makes them give some indication of their collective intelligence. Okay, so very quickly, what does correlate with collective intelligence? First of all, turn taking in the group. So the more even the distribution of the number of speaking turns among the group members, the smarter the group. So if you have a group where one person talks 70% of the time and the other people talk 15% each, that's not good. You want even distribution of turns. Proportion of women in the group. So you want more women in the group. According to this is the actual data for teams of 2 to 5 people. There's a little bit of a dip at 100%, sort of at the high end there, but it's not clear whether that's significant or not. And then finally, the mentalizing ability of the group members. So remember I told you we had this test of social sensitivity earlier. So this was a test called reading the mind in the eyes. I don't know if any of you are familiar with it or not. If you're not, here's an example. In this test you see just the eyes of a person, and you have to say what emotion or mental state they're experiencing. So is this person terrified, upset, arrogant, or annoyed? What do you think? Anyone want to guess?
Upset.
Upset, correct. Okay, so that one's correct. What about this person? Is this person playful, comforting, irritated, or bored? I heard someone say playful. Okay, that's the correct answer. Sadly, these are the practice items. It gets much harder after this. It's a very hard test. But having people on your team who score better at this test, even though it involves just decoding mental states from eyes, is associated with having higher collective intelligence. So one could say, well, how do you know that this is because of mentalizing ability? That is the ability to represent and think about the internal mental states of other people, and not just facial recognition ability. So we answered that question ultimately by having this online version of the task. So we and people at MIT and collaborators created an online collective intelligence test. There's a chat window, there are problems they try to solve, and various other things, timers and whatnot. There's a Sudoku puzzle. And we had teams come to the lab and either work face-to-face. So everyone sits at computers, but some of them sit so that they can see each other and they can exchange facial expressions and literally speak to each other. Or in a different condition, they were distributed in cubicles so that they didn't even know who else was on their team. There'd be sort of multiple teams present at once and they didn't talk, they just interacted entirely by computer. They could have been in different rooms or different states or whatever. But in each case, whether they were interacting face-to-face or online, teams with higher average scores on the mind and the eyes test also had higher collective intelligence. So it seems like that test is, to some extent at least, tapping into something which is not just facial expression reading, but maybe a broader measure of theory of mind or mentalizing, the ability to represent and think about what's going on in somebody else's mind, which could be very helpful for our group collaboration, right? So if if Chris and I are part of the same group and Stefano's in the same group and Chris says something stupid, and Stefano he can just roll his eyes at me, and I can sigh, and we don't have to exchange words and say, boy, Chris just did something stupid, didn't he? Yes, he did do something stupid. What an idiot! We don't have to do all that. We save time. We transmit more information, and so on by representing that information more concisely. Okay, so I'm going to go a couple minutes over with a few more little results, but so I think this concept of collective intelligence of small groups has several interesting implications. First, measurability of collective intelligence of groups can provide a foundation for a new approach to the science of group performance. Instead of just studying group performance by giving groups one task at a time to do and trying to nudge or manipulate performance on a single kind of task, we should be looking more broadly at the collective intelligence of teams and how to increase or decrease that and what factors go into that. Also provides a way to link individual and group levels in cognition. Collective intelligence might be easier to raise than individual intelligence. You can change the composition of teams, or you can engage in various interventions and processes which might be cheaper or more possible than changing the intelligence of individuals. Better understanding of collective intelligence can help to improve individual decision-making as well. So for example, having people make give multiple answers to the same problem and average them. And maximizing collective intelligence could be a strategic aim for larger organizations. Now, two final notes on research directions that come out of this. One is the importance of social intelligence or mentalizing or theory of mind. As far as I'm concerned, these are all words for the same thing. They are, the cognitive ability to understand other people, what they're thinking, why they're doing, what they're going to do next, and so on. That's, to my mind, social intelligence. So this measure of mentalizing was consistently a strong predictor of collective intelligence across many studies. And individual social intelligence might grow in importance as group work, grows to dominate economic life more and more. And this variable might have more explanatory power than we realize. So I'll skip the next point. The mind in the eyes test, however, has several drawbacks. So it's based purely on static images, just of eyes and faces. Those are not the only kind of social stimuli we encounter in everyday life. It may have gender-biased stimuli, so if you look carefully at them, you'll find that all the female images tend to look like models, and they're in sort of relatively seductive, expressions and so on, whereas the males are older and have different expressions. And may also tap verbal intelligence too much. So sometimes the mental state words are words that people don't know. So a glossary is sometimes used in administration of this test so that people will understand what the 4 response options even mean, which is then tapping into their verbal memory and verbal intelligence, not just social intelligence. So there are other tests of social intelligence, but they're even more verbal, like they rely on people reading a story of 3 paragraphs and then answering questions about why people behaved the way they did and so on. So one of my research projects now, which is in progress, is to create a new test of social intelligence for individuals to try to better measure this construct, which we think is really important for the success of groups and for the collective intelligence of groups. And we based our study on the famous video by Hyder and Simmel from the 1940s. They created a video in which there was nothing happening but shapes moving around, and yet they discovered that people sort of attributed emotions and mental states to the shapes as though the shapes were actual human beings. So, whoops. This was their original video. I won't play too much of it, but a triangle goes into a room. Another triangle is on the outside. The triangle comes out. The bigger triangle, most people say starts to bully and beat up the little triangle. The dot runs away, and so on. This goes on for like 90 seconds or something like that. Ami Klin and colleagues in 2000 used this video with people on the autism spectrum and found out that adults or teenagers, I believe, on the autism spectrum, when they describe the action in this video, use fewer words about mental states and goals and intentions and emotions and so on, and more words about physical things, like the triangle is going up, the triangle is going down, as opposed to the triangle is running away, or the triangle is attacking, or something like that. So there they finally run away. Run. Big triangle's kind of dumb. There's another attribution right there, breaks up the entire house looking for them, So to take advantage of that, we decided to try to develop a psychometric test along those lines using shorter videos. So I'll skip this initial version of it. Here's an example of what we've come up with. You're going to see a video with some shapes interacting on the screen, and when participants in our test see this, they see the question there, and they have the question on the screen while they watch the video. So who's being excluded? Okay, so who's being excluded? Yellow plus, okay, good. Again, that was an easy one. Here's another one. Who does orange X know the least? Okay, so the correct answer is supposed to be blue triangle. This is one of the hardest ones. Only 35% of people got this right, and chance would be 25% since there are 4 possible answers. So I'll skip this one. Yellow plus cuts in line at the porta potty, and nobody else likes that. So it's yellow plus who's being rude. Watch. Ooh, asshole. All right, so in a pilot study with about 130 M-Turkers, we found that we had most items were actually a bit too easy. So most items, about 81 to 90% of people are getting correct. We'd like to sort of shift this over by making the items a little harder. However, the situation is not all bad. Like most people get about 75 or 80% correct. We'd like to move that over a little bit more and make the distribution look a little bit more normal than it is. So we've run several other versions of this, and we have a large data set which we're now in the process of analyzing, hoping to generate an actual psychometrically useful collective intelligence test. I'm going to skip past this and go to one other project. We are finally using collective intelligence to create a new intelligence test. So we created a crowdsourcing contest to create a new regular intelligence test. The matrix reasoning test that we used, they're now charging something like $18 a use. The Pearson, the testing company, we didn't want to pay that much. And also, there are a lot of other research purposes for which you'd like to have more of these matrix reasoning items to better understand why they create such a good test of intelligence. So we ran a crowdsourcing contest. We got about 550 submissions of matrix reasoning test items from about 20 countries or so. And we awarded the submitters some cash prizes, but plus anyone who submitted an item that makes it into the final corpus of valid items gets to be a co-author on the article. So we're just starting to write up the article now, and it's going to have like 55 co-authors or something like that as a result, from like 15 countries or something. So I think that's kind of cool. Matrix reasoning items look like this. The goal is always to figure out which of the 8 items below fits into the bottom right corner above. And you have to infer what rules are being used and what the mechanism of the puzzle is in order to do that. This is a relatively easy item. I believe it's, you can see that there need to be squares and there needs to be 3. So it's probably 8, I guess, is the correct answer. However, they can be very hard. So this is a submitted item that we got. We never would have thought of a matrix reasoning item using this mechanism. It illustrates one of the well-known properties of crowdsourcing, that you get sort of like creative ideas that are completely outside what the core team would have thought of themselves. In fact, people have sort of created different kinds of matrix reasoning items that we never would have thought of, and we haven't seen in any other matrix reasoning tests, including very hard ones like this. So we have hope that this test that we're generating is actually going to have like higher resolution at the very high end, which I think is an interesting property of crowdsourced test items. Notice that there are many items where that are very hard. So chance is 12.5% because there are 8 choices. We have many items down around this area that are very difficult, as well as some easy ones, of course, which you have to have. I'll tell you more about that if you want later on. I guess sort of to sum up, the idea here is really been to take one of the most well-established constructs in psychology, individual intelligence, general intelligence, IQ, etc., and see if it applies to small groups in the most simplistic way we can, just by treating the group as though it was an individual. We'll test the group. We'll see if all the different tests that groups take correlate with each other. We'll see if the group score on those tests predicts other things that weren't included in the test and so on. And I think generally we have positive results. I have to say that other people who have done similar work, who have sort of tried to replicate or at least build on what we did, have not always found the same thing. They generally find that the tests correlate, but then the question becomes sort of what explains why some groups are smarter than others. Some people seem to believe that individual intelligence is a stronger contributor to collective intelligence than our results indicate. And I'm looking forward to hopefully even collaborating with those people and finding out sort of why we get those discrepancies. But generally, it seems a fairly solid result that groups that do well on one kind of task also do well on other kinds of tasks. And that's an interesting phenomenon that I think deserves more study and explanation and has wide application in other areas. So one way to go beyond that might be to look at the role of social intelligence as a building block for collective intelligence. So thanks for coming and for paying attention and for not minding as I race through the talk. Thanks.
Time for questions.
I have 2 questions. So one is you're looking at small teams, but I'm kind of wondering what about the size of the team? So how does collective intelligence change as you add more and more members? So
Yeah.
that's one thing, and the second thing would be given a team, can the team learn to increase their collective intelligence with some kind of like repeating tasks or
Right.
with intervention saying, oh, you should try that? Or,
Right, okay, good question. So, excellent question. So I would like to know the answer to both of those questions. Now, with respect to the size of the team, in the very first study, we only had 3-person teams. In the second study, we varied the team size from 2 to 5, and then used the team size as a covariate in later analyses, because with these tasks, larger teams tend to do better than smaller teams. As I think would be the default expectation for many tasks, that the more people you have, the greater chance you have of finding the right answer or of getting the work done quickly and so on. Although there are probably some pathological tasks where more people, make things worse. But for this particular universe of tasks, performance seemed to go up. Now I don't know whether it would sort of asymptote or reverse once you get to a certain level. Tom Malone has been working with one of his grad students, I believe, on trying sort of much larger teams, like 15, 20 people. Even 40, I believe, but I think there have been some technical difficulties in shared, everybody getting to type into the same document at once and so on. One important characteristic of this work is that, everybody gets to talk to everybody. Like the chat room is an all-to-all, chat, right? It's just shouting, into a room of people. Likewise, anyone can edit the answers. So the answers, I breezed past them quickly, like the crossword puzzle, the Sudoku, and so on. It's like a little mini wiki where anybody can just go in and edit any of the answers. Nobody has the authority, to answer for the team and so on. So when you have a much larger group of people, this can become a problem.
But you could do also something with teams of 4 or 5, but a lot of them interact. So that you have a large team of 20, 4 teams, and you see there's a collective intelligence, a team is a person, and you have a new team of 3 mega.
Yeah, I think that would be interesting. Although there are lots of degrees of freedom as to how does the group of 4 communicate its result to the other? Do they nominate a leader who then goes to make another group of 4? I mean, there are many different ways to do it. I agree that that's interesting, and I think one direction for this research in general is to move beyond the fairly simplistic, but I think pretty universal model of 4 people all talking to each other in a room. We've all been in many, many meetings where there are 4 people talking to each other across a conference table or in a room or something like that, but to move beyond that and to try to have sort of more complicated organizational structures. And that would perhaps, in part, start to lead to an answer to your second question, which is, what can we do to increase the collective intelligence of the team? Maybe everyone shouting at everybody else is not the best communication modality. One thing we have put in...
Sorry, but just showing the videos that you showed us of what is a bad team and a good team, how does that influence?
Oh, you mean just showing those videos? Don't be these guys, be these guys instead? Yeah. I never thought of that's an interesting one. I mean, one idea that we had was to give them continuous feedback about how much they're contributing. So that way, so if it's causal that having an equal distribution of contributions among the members increases collective intelligence, if that actually causally increases collective intelligence, then nudging them to do that by maybe giving them feedback like a meter that shows, Chris, you've been talking for 97% of the time in this seminar, you should let somebody else talk, or maybe even a less subtle, version than a feedback meter or something like that, perhaps actual budgeting, of talking time or something like that might work. So I'm definitely interested in those kinds of interventions. I think one thing we need to do methodologically to improve this research program, which I'm trying to do myself, is to shorten the collective intelligence test so that we can have people be in multiple teams. Because it would really help us understand, I think, the causal structure of what's going on if we could see whether there are some people who increase the collective intelligence of teams they're in and other people who decrease it across multiple teams. Because if we're only letting them be in one team, there could be all kinds of idiosyncratic things going on from that combination of people, that makes a difference. It would help us understand this causality better also. Did I address both of your? I think I addressed both of your questions, but there are lots of answers to the one about how to help the teams be, do better, and I think that's a really fruitful area for more work that I'm hoping to do more of. Yes, sir.
I think your work's incredible. It has a lot of applications to health as well. We think of patients and their families as sort of a collective team.
Mm-hmm.
I'm wondering if you can you espouse certain risk factors? Could you say that a lack of diversity in a group is a risk factor for lack of collective intelligence, and that perhaps people over-speaking each other is a risk factor for lack of collective intelligence? And could we explore that? in other contexts?
That's an interesting sort of like negative framing, like risk factors. You know, that does sound like a healthcare kind of framing. And since I'm in a health system, I should be thinking more in those ways. I hadn't actually thought of it that way as a risk factor before, but it's just the flip side of a positive factor. That would be my bet. Now, by the way, the diversity situation I don't think is clear. Like the only significant effect that we have found, I believe, is a positive effect of more women. So that's not diversity, right? That's just like a positive effect of having women on the team. It's hard for me to actually believe that that's a universal thing. There may be something about our setup, our particular tasks, that maybe makes that a linear effect. Maybe in reality it's more of a curvilinear effect where you don't want 100% men or 100% women, you want some kind of mix, all else being equal, of course. I should say one of the reasons why the teams with more women did better was that women were doing better on the mind and the eyes test as well, so that was partially a mediator of the effect of having more women on your team, was that you also did have better social intelligence, I guess we could say. And we're not the only people who have found that women tend to score better on social intelligence tests. That's it's not a huge effect, but it's a pretty commonly found effect. I like to think these things are causal. So if you're talking about sort of like the family as a team, it would seem that if they're talking over each other, and not letting some people say what they're thinking and so on, that would seem to be a bad thing. I guess you could say the same for the physicians and the nurses as well, and the people in the operating room and so on. I just was listening to or reading some checklist stuff about the checklist of introducing everybody on all the nurses and surgeons and technicians and so on to each other, and understanding why they're there and so on, as a device to potentiate the likelihood that later on they will speak up if necessary. Like if you've been introduced to the group, if you've already said your name and and so on, you will be it'll be easier for you to talk the next time when it's really important that you actually say something. So that could also be an intervention if we impose sort of a round of introductions. It seems kind of trivial, like that's the way we begin a lot of meetings, right? The round of introductions, but maybe it is actually a truly efficacious mechanism compared to just we all walk into the room and start talking about whatever the topic at hand is. Maybe that socializing and introductions actually has some causal value for collective intelligence. That would be, always nice to validate, common sense when possible. I think validating common sense is actually not a very bad use of social science at all, because there's so much common sense that's invalid. So when we can actually validate some of it, we should, because we need to tell apart the valid from the invalid common sense, right? I think I saw you next, and then you.
So I'm interested in a lot of the actual experimenting on this. A lot of the tasks seem like they're very heavy on relational similarities between this abstraction that you have these triangles and they're fighting with these squares, and you can imagine putting a human in that, or there's an easier mapping between the behavior of these abstract things with things that you may know in your life. But then in other circumstances, it seems like a sort of I don't want to say arbitrary in like a bad way, but arbitrary projection of the scale of the type of problem that skills that we value in teams need to solve. So there could be somebody who's an expert at some micro task within a larger problem that this team is trying to solve, but maybe doesn't add to the collective intelligence of that team because, or maybe does because they can solve some micro part of it. And so I'm just curious about how you think about the scale or the size of the tasks that.
That's another really good. I think it's another really good point. So we were just talking about this kind of thing earlier today. So all the tasks that we've used, generally we try to pick tasks that don't require any special knowledge that people may have had before they came in. So for example, those matrix reasoning tasks, completely abstract reasoning. Now some people might have certain cognitive abilities which are useful for those things, but sort of no knowledge or expertise, per se. However, in the real world teams are often doing tasks that require lots of highly specialized knowledge, and people wouldn't even be on the team at all if they didn't have at least one aspect of that knowledge, right? Going back to healthcare, right? You don't just have 6 guys off the street come in and put them in the operating room and tell them to get moving on it, right? So in the real world, there's obviously an interplay between specific skills that must be present in the team and the collective intelligence of the team as a whole, and it's not always easy to just swap someone out who's making the team worse, right? You can't get rid of the surgeon, and replace him, with an executive, hospital executive, because the hospital executive contributes more to collective intelligence. These are tough, I think these are tough problems. One thing I do think, though, it's a hypothesis only, is that teams with higher collective intelligence should be more likely to assign the experts within their team to the tasks that the experts are best suited to. A guy at the CIA, who I think was long since retired, but he used to tell this story about how one of the reasons why the original Al-Qaeda terrorists who attacked the World Trade Center and so on succeeded in going up against a much larger, more well-financed, better resourced enemy, namely the US government and US infrastructure, was that they brought together sort of like a unique combination of expertises, and they used, they used them well. So it turns out many of them were engineers. They had, thought sort of like about things like, structural integrity of buildings, and so on. And they had gone and gotten specific training. Some of them knew how to fly planes, some of them didn't, but were thought to be better with weapons and whatnot. I mean, it's sort of gruesome to think about, but in a way, that organization sort of like made effective use of assigning individuals to the right roles. And I think that's certainly an aspect of collective intelligence, is not sort of everybody just contributing to everybody, but knowing when to specialize and who should do what.
I forgot to ask the second part of that question too, which is, does it actually can you see the effect of that scaling problem in the actual PCA? So like, basically, is PCA the right way to look at if there's these precise fine-tuned differences that some
So
this is I also don't know the answer, but I'm
I don't. So I'm trying to think of like exactly concretely how that would look, because we don't have we don't have individuals doing these tasks, right? It's only the group that does the task. So if you wanted to sort of, I think, detect a trace of some individual like making a certain contribution, you might have to do that by somehow like looking at the videos or something like that and seeing if there's a guy or or a woman who's always like offering some kind of important information or something like that or whatever. That would be sort of, I think, a potentially interesting but painstaking process to try to sort out the individual contributions, because we never let the individuals answer any of these problems. It's not even a two-stage thing. Like a lot of group process studies are a two-stage thing. Like everybody solves the problem as individuals, then they talk together, and then they do it again or something like that, which is nothing wrong with that design. It's just not what we did in this case. So it might be hard to actually sort of sort that out. Though there's plenty of evidence to think that groups will not make the best use of individual talents and so on. Often it's like whoever talks first, whoever will sort of lead the group, even if they don't have the most expertise in the in the topic that's at hand and so on. So I'll think more about that.
I think we should take your questions, but I also want to be respectful of everyone's time. So maybe you can just come up here and we can have another conversation, or everyone else who has a question. Otherwise, I'll get back to work and do what other things you have on your plate for today. And thanks, everyone.
All right, thank you guys for coming.